Imagine your vehicle's engine having to restart every single time you press the brake. They'll be extremely inefficient and you'll go broke because you have to replace all of the parts that'll be damaged because of doing this. This is the same situation that you face when you don't implement connection pooling. But to be fair, there's a technology for engines called auto start stop technology feature that has been implemented in vehicles throughout these years, right? My vehicle has it and I always disable it because apparently, I don't know, it consumes a lot of energy and I don't have enough knowledge to deduce whether this is actually useful. So this is not a conversation about automotive engineering, it's a conversation for databases, but the analogy applies. So the same thing applies for your database. Because when you connect to another service, in this case, your database, you need to go through a series of steps, different stages to establish a secure connection and actually being able to run queries in that service. So knowing what happens on all these steps will be important because that's how you understand the implications of implementing connection pooling, which is a non-negotiable. If you're not doing it, buddy, you're wasting resources. So the first thing that we need to understand is, okay, it's like connecting your application, trying to connect to any kind of service. So your service is right here. So you are the DB, and we need a way, right? Your application needs a way to connect to that application, right? So when I say this server, it could be any kind of architecture, right? You can have your server in another cloud provider, and I hope you're not in the majority of cases because I have a video that I'm going to link right here about why you shouldn't use the cloud. I have to update the video because a lot of things have changed since then. Not about it, but about myself. And this architecture, this principle applies for any kind of thing. Even if you're doing microservices in the same host, it applies the same process, the same networking process. So we just need a way to authenticate it and being able to connect to this service and run queries. So to be more specific, so you know how this process works, there's a series of steps, and this series of steps will consume resources. And these resources, as anything in computer science, we need to manage resources. So we are efficient, we save time, and we can serve more users, right? We even save money in some cases. So the first thing that happens is the DNS lookup, right? So you have a connection, you have an application, and your application could be Python, it could be Node.js, it could be any kind of framework that uses a specific type of library to connect to a database. So you have your application, and the first thing that happens is that your container needs to query a DNS, needs to know, okay, I have this IP address, and then I need to know what is the DNS, like what is its name, how do I reach this DB? So that's the first thing, and it consumes resources. So we're gonna have a metric right here. The metric is RTT, RTT, which is, I think this metric is actually useful to measure latency. If we want to be more specific, RTT is rate time. Uh, Damn, I forgot. But RTT is actually a metric to understand how long does it take for a packet from going to point A to point B and receive an acknowledgement. So I might look it up, but it's RTT. So we're gonna use this metric, right? So okay, we have 1 point after the DNS lookup. Okay, we figured out what is the IP address, but then we need the TCP handshake, which is the backbone of the internet, and it happens everywhere to establish a connection. That's another RTT. And then you start consuming more networking resources, allocating more sockets, and using more CPU and memory. After you get the TCP handshake, hopefully you have a TLS SSL, which is not as strictly enforced, but it's ideal because otherwise your credentials will travel in plain text. You don't want that, or even if it's in the microservice architecture in the same host. I mean, I don't know. It's always best practice, but this adds another. And this is actually a little bit of expensive because of the cryptographic certificate and the certificate exchange. It quite consumes CPU and memory, right? Then after that, you establish an encrypted or you upgrade the TCP connection to an encrypted connection, then you have the protocol sorting, and that's when your application tells the DB, okay, we're gonna use this protocol, we're gonna use this as standard to be able to change my credentials. So that is another point. And then you got the actual authentication exchange. When you send the password and you establish a secure connection with the database. I get it. This is important to understand because this is the steps that you're gonna follow if you don't implement connection pooling every single time. But hear me out. Just stay with me a little bit more time. So we have the auth change. Now, after we are able to authenticate the application with the database, then we have the session creation. Okay, we finally have a session, and with this session, then we can actually run queries. Then the client initialization, which is different than the session creation, because the session is the database acknowledging that you can start a session, but you don't know how. And this is actually handled by your client. So, for example, if you are using Python, it could be SQL Alchemy, or it could be RPG, or any kind of ORM. So the client does this. So for example, with Prisma, it does the same thing. Although I don't like Prisma. Okay, Prisma has some limitations. Has a lot of limitations. But the point is that the client initializes the connection, and only after that, only after all of these things happen, that's when you can actually run your application query. So you can create your table and return data that could be used by the front end. Only all of this. Okay, this is good because you might be thinking, okay, this happens lightning fast. This happens actually very fast. And yeah, it's true. But the thing gets a little bit difficult when you start having more users. When you actually have users and you have to run this sequence for every single user's query. Oh man, imagine if you like to blow up things, that's why you shouldn't implement connection pooling. So we have all of this, which we already know that it consumes resources. We need to skip this. We can't do this every single time we have to run a query, because otherwise we're gonna blow the thing up. So we can skip all of this, just doing it once with connection pooling. And now, what is connection pooling, which I've been mentioning since the beginning of this video, is basically a way to skip all of these processes and having a connection that is always open, and already handle all this process, is already authenticated to the database. And then since this is already open and connected directly to the DB, then it can just receive no connections, without going through this whole process that consumes a lot of resources. So basically, the connection is always open and ready to start executing queries, right? That's why it's more resource effective. Okay, now you understand why connection pooling is important, but as everything in life, there are trade-offs, all right? And the main trade-off with connection pooling is how do you configure the actual pool, right? Because you need to have certain configurations just to make it efficient, all right? And good rules of thumb that different people will implement, but I'm gonna tell you mine, which have been very helpful in my projects, in my career, and everything, and are worth mentioning. So the first thing is, as anything in technology, you can go down the rabbit hole for as much as you want. So we're just gonna keep it straightforward for this case. The first thing, once you implement connection pooling, because you understand the trade-off if you don't, is the pool sizing. That's the first thing. That's the first thing that you actually need to dedicate some time to think about it. Why? Because as any backend process, once you open a session and the DB is allocating server resources to run the database, to run the service, the pool sizing, or the actual pool, is a connection that is always open. But if this is a connection that is always open, and you don't define a specific amount of simultaneous connections that your pool can handle, just imagine you have no control, or at least no way to predict, a way to try to predict how many connections you're able to serve simultaneously, right? depending on your server resources. So the pool sizing is basically defining, okay, I want that this pool, which is a connection that is always open between my application and the DB, I want this amount, this maximum amount of connections that could happen simultaneously. Because if you don't define this, then by default, the library that you're using for connection pooling will assign a value for you. And then you won't have control. I wait just to decide, okay, this is what's going to happen if I have more connections than this. How do you come up with that number? Okay, that's another conversation. If you go online and look it up, you're probably going to find a formula that is actually outdated because it's using is considering HDD hard drives rather than SSD, which is a huge difference. So my suggestion is just run the numbers. Just look at your server statistics, and if you have a high input output in a specific service or running metrics in this container, and you identify any bottleneck, that's the only way. Okay, at least that's how I do it. That's how it works. It might be a better way. If there's a better way, just drop it down in the comments down below. So the pool sizing is important, so you have to dedicate time to this. I would say the real resources, the real metric in terms of resources that actually defines this number is the number of CPU cores. All right, so that's at least what I take a look at. So I usually do 15 to 20 if I have two vCPUs, considering that you are running a VPS. So that's the first thing, and I think it's important to keep it in mind. Then the second one is timeouts. Why do we need timeouts? Well, because not every query, not every single query will take the same time as others, right? Because it depends on your application. This number is extremely subjective because it depends on your application. Because if you have a lot of latency, you have to make a lot of checks in your queries and you don't have that thing optimized and a lot of different factors, then you probably need a higher number for a connection timeout. But what is the difference between the connection timeout and the idle timeout? Well, the difference is that for connection timeout, you define the time that a connection is alive, while in the idle timeout, you define the time where the connection could exist before being closed. So the pool liberates or frees up more resources for upcoming connections. So that is the difference between these two. Again, this depends on your application, but a rule of thumb that I always do is setting the idle just slightly less, slightly shorter than the connection. So this one is a little bit shorter than this one. That's exactly what I do with the timeouts. But again, if you identify any bottlenecks in the statistics of your container or your server, those are the key metrics you're going to take a look and play with the numbers. So finally, I would say that these three metrics are more than enough, at least for basic scenarios. There are of course more configurations, but I think those are the ones that once you decide, okay, I'm going to use a connection pooling, you have to dedicate some time, put some effort into thinking, okay, I need these numbers. There's another one, which is when I feel elegant and I want to put more, more style into the setup. So it's connection validation. And this is actually cool. I don't really see too many people who really thought about it, or developers or entrepreneurs or whatever, because I mean, it's needed, but it's just it's a good to have, right? If you just want to follow the standards. So this is the concept of connection validation. So you have the connection pool, which is open, right? But how do we know if this connection pool is safe? It's actually working. It's actually working properly. So we can start a new connection and we can immediately run queries. Well, that's what connection validation gives. So it's basically, I call it the pre-query, right? So you have the pre-query, and the pre-query is basically a way to run a query just to identify whether this is healthy. It can accept new connections. So the pre-query is extremely helpful, especially for connection validation, because it's a way for you to yeah, to identify that this pool is still healthy. You can make the analogy with if you are familiar with Docker Compose with health checks. It's I would say it's quite similar. So basically, once you implement connection pooling, you don't have to do all of this. All of this. You don't have to do it. You go straight to client initialization. So you save tons, tons of resources. Now, to wrap up, this concept, this principle can be applied for a lot of things. It's not only specified or only applied to relational databases. It could essentially be applied to any kind of service that you need to connect to in order to run operations in other kind of databases. For example, Redis. Now, there's one thing specifically with Redis. It is that connection pooling is not as critical in Redis because of the architecture and the way Redis is built on. So, for example, Redis, since it's single threaded, and the protocol is quite straightforward, connection pooling is not as needed as in relational databases, although you can implement it. And I think a lot of libraries have it already built in, right? It's not like, okay, you need to put more time into configuring this thing, like in a pooling in a relational database compared to Redis because yeah, it's more straightforward. Okay. But that's a conversation for another topic when we decide to talk about Redis, which is again extremely helpful. So I hope you have it a better understanding of why you need connection pooling. All right. And if you combine connection pooling with Redis, with Cache in the client side and in the server side, buddy, you don't have to worry about bottlenecks in your BPS in your server. And that's when you can put some competitive prices in your business, in your software, or your startup, or whatever. So those things are important. Next video is going to be about Redis and more computer science stuff. So see you in the next